Bismillahirrahmanirrahim. Dear students, welcome to the course of Artificial Intelligence. Today we will discuss lecture number 13, and the main topic of the lecture is learning. This is your teacher Tariq Aziz, lecturer at Institute of IT, Kohat University, HANGU-CAMPUS. So let's move on to the agenda. Dear students, in today's lecture, first of all, we will discuss that what is learning, and after that, we will discuss that what do you mean by machine learning, and then we will discuss that why do we want machine learning, and then we will discuss some phases of machine learning, and then we will discuss some available learning techniques, and finally we will discuss the applied learning. Now dear students, the first topic is that what is learning. So basically, there are no decisive definition of learning, but there are some definitions by some researchers, we can say, by some authors. So we will look at these definitions by different authors. The first definition is by Herbert Simon, and it defines learning that learning denotes changes in a system that enables a system to do the same task more efficiently the next time. So, for example, if a system is performing some sort of task today, and after some days or after some time, if the system is able to perform this task again, then it should perform this task more efficiently next time. So this is called learning. Then there is another author which is Richard uh, Michael. Michael. I may not pronounce the name correct, but you can search for the name. So he says that learning is constructing or modifying representation of what is being experienced. And then there is another author which is known as Marvin. He defined learning that it's making useful changes in our minds. So there are some these are the some definitions by different authors of learning. Now, dear students, uh, if we want to define learning, then human beings, with respect to human beings, I would say that human beings learn from their experience. Like when you were a child and you don't know the difference between the hot and cold. So if you come across the entities, the hot entities, and then at that time you have some learning of these hot entities, and in the next time you will take care about these entities. So this is basically learning. Now dear students, the next topic is that what is machine learning then. So as we said that being a human beings, we learn through our experiences throughout our life. Now we want machines to learn as human being. Dear students, we discussed about two types of artificial intelligence. One is known as the weak AI, and the second one is known as the strong AI. With respect to weak AI, we said that program whatever machine, if we program for a specific task, then it will perform the specific task for each and every time. It will not learn whatever the input is given to the machine. It will process this input, and then accordingly it will produce the output, but there will be no new thing. So this is the weak AI. But with respect to strong AI, now machine learning, it basically comes under the heading of the strong AI, that we want machine to learn from their experience as humans learn from their experience. So this concept comes under the heading of the strong AI. Now, what's the motivation? Motivation is that we want machine learning. We want our machines to learn like human beings learn through their experience. Now, it says that the first point that it is very difficult to define precisely what machine learning is, but we can speak generally that the goal of machine learning is to build a computer system that can learn from their experience. As we said, that human beings, it's a natural process that they learn from their experience. Now we want machines to learn from their experience, and also we want machines to adapt to their environments. Human beings, they adapt to their environments. They For example, if you are living in a hot place and then you move on to the cold place, so this is the system is built naturally in the human beings, that they are adaptive according to the environments. So now we need two things with respect to machines. First of all, we need that machines should learn from their experience. And the second thing we want is the adaptation. Machines should be adaptable according to their environments. If we achieve machines like this, then this is called machine learning. Okay. Now, dear students, here in the third point, it says that it's obvious thing that learning is one of the important aspect or one of the important component of intelligence. And in fact, with respect to learning, some people, they say or they think that if there is an intelligence, then there should be or there must be an ability to learn. But if there is nothing to learn, or but uh, uh, if there is no ability to learn, then this is not intelligence at all. But this is different viewpoint of different people. Let me repeat the concept again. Dear students, some people think, this is their point of view, that if there is some ability to learn, then it means that this is intelligence. But there is no ability to learn, then this is not intelligence. So this is different viewpoints of different people. Now, dear students, the second thing here I already discussed, that other people think that intelligent system has a separate learning mechanism, and this learning mechanism then improves the performance of other mechanism of the system. Okay. Now, dear students, the next topic is that why do we want machine learning? As we discussed that now we want machines to think. So this is the basic point. Let me repeat the concept of the weak AI and the strong AI again. By strong AI, we means that we want machines to think. So this is the strong AI. But with respect to weak AI, we want a machine to act like human. So if a machine acts like human, then we can say it's belongs to the weak notion of artificial intelligence. But if machines are able to think like humans, then this belongs to the strong notion of artificial intelligence. So here in the first point, uh, it says that one response to the idea of AI is to say that computers cannot think. As I discussed that, then it will come under the heading of the weak AI, because they only do what their programmers tell them to do. Now, dear students, with respect to programs, it says that, however, it is not always easy to tell what a particular program will do. Okay, what we have to do, the program is given the same inputs and conditions. We give some same inputs to the program and some condition, and then based on these same inputs and conditions, it will always produce the same outputs. Okay, so this is the weak AI. As I discussed, that we program machines, we give them some same inputs, some conditions, and based on these inputs and conditions, it will always produce the same outputs. Okay, there will be nothing new. Uh, if the program gets something right once, okay, if the result is right, then it will always get it right. But if there is a mistake in the result, then the program will produce the same mistake every time it runs. Okay, so there is nothing new, there is no adaptation according to the environment, there is no learning. Simply you have to input to the machine, to the program, then program will process and it will produce the output. If the input is right, processing is right, will be right, and it will always be right. For how many times you run the program, let's say for 100 times, if you run the program, if the program output is right, it will always be right for 100 times. But if there is a mistake in the program, if you run the program 100 times, the same mistake will appear again and again. Okay, so this is the weak notion of the artificial intelligence. But now, in contrast to computers, what humans do, humans learn from their mistakes, humans learn from their experience. They attempt to work out why things went wrong, and alternatively they proposed solutions to these wrong things. Okay, so also, human beings, they are able to notice similarities between things, and therefore can generate new ideas about the world we live in. Okay, now, dear students, again, an intelligence that did not learn would not be much of intelligence. With respect to this point, I discussed previously that some people think that if you are not learning, if the system is not learning, that then this is not an intelligence at all. So this point here, actually this slide is about the strong notion of the artificial intelligence. And as we discussed, the humans, that humans learn from their mistakes, humans learn from their experiences, they proposed new solutions to their problems, they proposed alternative solutions to their problems. They are able to differentiate they are able to notice similarities between things, etc. and etc. So if machine perform all these tasks, then we can say that now machine is learning, and now this is the strong notion of the artificial intelligence. So here it says that machine learning is basically prerequisite for any mature program of artificial intelligence. If you want a mature program with respect to artificial intelligence, then this program should learn before. Okay, now dear students, the next topic is regarding the phases in machine learning. Now there are three phases in machine learning, and who proposed these phases of machine learning? Janet Fenley in 1996. He basically proposed these three phases of machine learning. So if we want our machine to learn, then machine will go through these three phases. First of all, the training phase. Definitely we have to train our machine. So what we have to do then, we have to provide the set of examples of correct behavior to the machine, and then it will for what purpose? For analysis purpose. And then there should be some form of presentation of the newly learned knowledge, and the machine should store this new knowledge. So what the human being basically they do, they absorb the same concept. They bear the human a human being actually they bear the same concept. For example, what we do, by using our five senses, we get input from the environment, and then we analyze, we process these input, and finally we represent these inputs in our brain by using some sort of representation, and we store this knowledge in our brain. So same is the case with machine learning. Dear students, at this stage, let me clear that what we are doing basically, we want to build machines which learn, which is capable of learning. Again, we want to develop machine which are capable of learning. So that's why we will analyze the behavior of humans, and according to these behaviors, we will try to model our machines. That's why I said that here at this point, human beings they do all these things. So, if we want to develop a machines who are capable of learning, then these machines will go through these three phases. So the first phase is the training phase. Definitely, we have to train our machine. So what we will do, we will provide some set of examples to our machine, and then it will okay it will process these example, and then it will represent these example in some form of representation, whatever the representation form is, and then the machine will be able to store this knowledge in his memory. But the what will be the form of the representation, as we discussed in the knowledge representation and reasoning phase, that this form of representation can be rules. So by using rules, machines will represent knowledge and then store this knowledge. Then the second phase is the validation phase. The rules are checked. In this phase, these rules, they will be checked, and if necessary, additional training is given. Sometimes additional test data are used, but instead of using a human to validate the rules, some other automatic knowledge based component may be used, because we want to develop an intelligent machines. So definitely we want some automatic knowledge based component. Okay. Now, dear students, the role of this tester is often called the critic. Now, what is the third phase? The third phase is the application. The rules are used in responding to some new situations. Okay. And then these phases, okay, this is the final phase of application. In the final phase, what we have to do, we have to provide some rules used in responding to sorry, we will provide some new situation to the machine, and then we will check the rules against the new situations. Okay. So this is the application. Now, dear students, these phases may not be distinct. So how? For example, it says that there may not be an explicit validation phase. Instead, the learning algorithm, it will perform the validation phase too, and it will guarantee some form of correctness. Also, in some circumstances, system learn on the job. That is, training and application phases overlap. Okay, so that's why these phases may not be distinct. Now, dear students, the next thing is the inputs to training. So definitely, dear students, what we want to do, we want to develop a machine who is capable of learning. Now, dear students, the main thing is that how we will provide input to the machine. So definitely, in the previous slide, I said that we need to train our machine. So for this purpose, what we have to do, we have to provide some inputs to the machine. Now, dear students, it says that you have to be careful. Infrequent situations may simply not be the training set. Okay. First of all, we have to provide some inputs to the machine, and we call these inputs the training set. So this training set must be frequent. Okay. They may not be infrequent situations, and we will discuss this with the help of example when we move on. Alternatively, the examples may have been generated by a teacher. So it says that the input training set are the input examples. They can also be generated by a teacher who is training the machine. Now, in this case, it can be assumed that they are a helpful set which cover all the important cases. And then also it is advisable to assume that the teacher will not be ambiguous, because if you provide the ambiguous examples, then definitely it will create a problem. So while inputting the training set, the teacher, he has to avoid the ambiguity in the input. Okay. Now, finally, the system itself regarding the input. Now, dear students, regarding input, we discussed three things. First of all, we discussed that the input training set should be frequent, it should not be infrequent. The second thing we discussed that the teacher who is training the machine, he can generate the input training set. Okay. And the third thing is that the final thing is that the system itself may be able to generate the examples. How? By performing experiments on the world, or asking questions from the expert, or even using the internal model of the world. So these are the three ways to provide inputs to the machine as a training set. Now, dear students, here it says that representation is necessary. As we discussed previously, that representation of a problem is very necessary for problem solving. So here it says that some form of representation of the example has to be decided. Now, in the previous slide, we said that we have to provide some inputs as a training set to the machine. But these inputs should be represented in some form, and we have to decide this representation. Okay. Now it says that there may this may partly be determined by the context, but more often than not there will be a choice. So it means that in which context you want to use your machine, you can decide or you can choose this representation technique or representation form with respect to the environment or the context of the machine. Or finally it says that often the choice of representation include quite a lot of the domain knowledge. Okay, so we know about the domain knowledge. So the technique for representation, the method for representation can also be decided from the domain knowledge. Okay, but it's very important that you have to represent these input training sets. Now, dear students, then the output. Okay, we provided the input training sets to the machine. So what will be the output training sets then? Who will determine these outputs training set? The application. Okay, so the output training set will be determined by the application. Now this here is a this here the question is that what is it that we want to do with our knowledge. Okay, many machine learning systems are classifiers. So here at this point you have to specify that you what you want to know. Okay, what you want to do with your knowledge. Okay, so at this point it says that with respect to machine learning there are machines which are classifiers and they classify between entities. So as an example, we give some classes to machine, and what's the purpose of the learning? To determine the common feature in each class. So let's say we provide two or more than two classes to machine, and then we want that this machine determine the common features in each class. Okay, so as we said that this machine will now act as a classifier. Now here, dear students, uh, when a new unseen example is represented, so first of all what we will do, first of all initially we will provide some classes to the machine, and then if we want that machine should learn, then what will be the purpose of learning? The purpose of learning will be that machine should determine the common features in each class. Once it is capable of finding these common features in each class, then after that what we will do, we will provide some unseen example to the machine. The system or the machine uses the common features. Again he will perform the previous step. Again he will try to find the common features, and then the machine will try to determine which class the new example belongs to. So if it is succeeded, then it means that our machine is learning now. So this sort of job classification is often termed as concept learning. So if our machine is now capable to learn this new thing, how? Let me repeat the concept again. First of all, initially we will provide some classes to the machine, and then for the purpose of learning, machine will determine some common features in each class, and after that we will provide a new example to the machine, and based on identifying the common features in each class, if the machine determines the new class belongs to which example, or to determine which class the new example belongs to, If the machine is capable of performing this point, then we can say that now our machine is performing the concept learning. Okay, so this job classification is basically known as concept learning, and we will discuss this concept learning when we move on. Now, dear students, uh, here it says that uh, on the previous slide we just discussed the that we can have machines which classify, which perform classification. But it says that not all learning is a simple classification. We have robotics, and we know about the robotics. So, in with respect to robotics, are in applications such as robotics, one wants to learn appropriate actions. So now, with respect to robotics, our aim is to learn the appropriate actions, not the classification. So in this case, knowledge may be in terms of production rules or some similar representation. Okay. Uh, what we mean to say that there are a lot of applications of machine learning, not just the classification. Now, dear students, the training process. Okay, what's the training process? Real learning involves some generalization from past experience, like the human beings they do. So what we do basically, we accept some inputs from the environment, okay, and then we analyze these inputs, and finally we produce some generalization. Okay, so let me give you an example of the of an animal like a dog. We know that dog have four legs and a tail. So by experience, I know for the first time, definitely when I look at a dog, so I will realize that it has four legs and one tail. And then for the second time, when I saw the dog again, so I will make a general statement that anything if has four legs and a tail like dog, so it will be a dog. Okay, so this is the ability of a human being. Now, what we want as a machine learning, we want this generalization from past experience. We want that a machine should use their past experience, and then they should generalize things like human beings do. Okay, so this is the real learning. This is called real learning. Now, for this purpose, okay, what real learning involves, the second thing is the coding of memories into a more compact form. Okay. Now, dear students, if we achieve this generalization, if we want to achieve this generalization, then definitely we will need reasoning. So we already discussed about the reasoning, and we discussed the different types of reasoning. I would suggest that you should revise your concept regarding reasoning. But here, with respect to machine learning specifically, we will try to differentiate between the deductive reasoning and the inductive reasoning. So, okay, here it says that the difference between deductive reasoning and inductive reasoning is often used as the primary distinction between machine learning algorithms. So, if we want to differentiate between the machine learning algorithms, then we have to differentiate between the deductive reasoning and the inductive reasoning. Okay. Now, dear students, on the next slide, there is a difference between the deductive reasoning and inductive reasoning. So deductive learning, it basically work on existing facts and knowledge, and then by using these existing facts and knowledge, they deduce new knowledge from the old. So this is the deductive reasoning. Now, what about the inductive learning or inductive reasoning? It basically uses examples and then generate hypotheses based on the similarities between the examples. So it says that one way of looking at a learning process is as a search process. So one has a set of example and a set of possible rules. Two things: set of examples and set of possible rules. Now, the job of the learning algorithm is to find suitable rules that are correct, with respect to the example and existing knowledge. Okay, let me, in the next couple of slides, we have the difference between the inductive and deductive reasoning. Now, dear students, this is enough for today's video lecture. From the next video lecture, we will discuss the available learning techniques, and there we will try to differentiate between the inductive reasoning and deductive reasoning. Thank you.